what I'm going to start with is a reminder of, here is an entry on the periodic table. You do have on your periodic table on the lower left-hand corner a key that tells you what all these numbers mean. But in Unit 1, we were concerned about this value right here, the density value of something. Today, well, the symbol we always have to be aware of, but today we have to go over what the atomic number means, what the average atomic mass means as well. Later on in this unit, we do have to go over what it means to have possible charges and what the electron configuration is as well. So really, at the end of this atom unit, we will know how to read a periodic table entry and what all the numbers stand for. So that is kind of our goal, is to figure that out. When we represent an atom, there's a couple different ways we can do it with what's called an atomic symbol. For example, I could have a superscript 12 with a C. It means the exact same thing as carbon 12. Now, on the bottom of this page, I say we need to be able to use atomic symbols to determine the number of each type of subatomic particles. This top number right here, which is the same as this number right here, is the mass of an individual atom. The mass of an individual atom is equal to the protons plus the neutrons. If you recall from last class, we did a reading guide, and one of the parts in the reading guide when we went over it is electrons' mass is really, really, really tiny compared to the mass of protons and neutrons. So small that we really don't even consider it in part of its mass. So, to me, it's analogous to, I step on a scale, I take my weight, and then I get a haircut, and I take my weight. Did I lose mass? Yeah, because hair has mass. Is it enough to shed those last couple of pounds? No, it's not. So, sure, it's a part of the mass of the electrons, but we really don't even consider it. That's why you see a whole number for the mass number of something. So we know that the mass is a combination of 12 protons and neutrons put together, because all the mass number is a counting thing. If I go back to the first slide, the atomic number is an important number for us to know now. Last unit, I used the atomic number for you to simply identify where on the periodic table that element is. So people would be looking around for iron. I can't find iron. Well, iron is atomic number 26. Oh, I can find that. Atomic number is the number of protons. Every element has a unique number of protons. Protons are really the identity of an element. So when you look at the periodic table, the very first element is hydrogen. Hydrogen has one proton in its nucleus. If there's an element that has one proton in its nucleus, it can only be hydrogen. If you look at the periodic table at element number 10, neon. Neon has 10 protons in its nucleus every single time. So to me, that atomic number that you saw in the periodic table, again, that number in the upper left-hand corner, that is the identity of an element. The number of neutrons you will learn today can change. The number of electrons can change. But if you are a particular element, your protons stay the same. So if you're looking at your periodic table right now, how many protons does carbon have? 6, right? Again, hopefully we're all looking, we all need to learn this material. That means if carbon, in this example, has 6 protons, how many neutrons must it have in order for it to have a mass of 12? 6. By the way, P with a plus sign is the shorthand notation for proton. P for proton, plus because protons are positively charged. N with a 0, meaning it has no charge. Neutrons are neutral. The third type of subatomic particle is an electron. If an atom is neutral overall, it has no charge, the electrons equal the number of protons. So in my particular example here, Carbon 12 also has 6 electrons. Now, this is not always the case where the number of protons is the number of neutrons is the number of electrons. I believe in 8th grade, sometimes they try to simplify it and tell you, hey, the protons and the neutrons are the same amount, just to make it a little bit easier on you. But it's not always the case, and that's something that we have to expand upon today. One more thing I want to go over with these atomic symbols and the number of subatomic particles is something I just stated before. If protons and electrons are the same number, it's considered a neutral atom. However, just like on the homework sheet you did, some things have a charge. Those are called ions. An ion is a particle with a charge. I'll give you 2 examples in the bottom of the sheet here. Cl minus 1 and Mg plus 2. Let's look at these 2 quickly, and then we're going to give you a little time to practice identifying subatomic particles. If I look at the Cl minus 1 first, how many protons does chlorine have? Let's look at our periodic table, see what we can find. Gene, how about you give us this one? Chlorine, how many protons does it have? Looking at that atomic number, that blue number in the upper left-hand corner for each entry. Kate, can you find chlorine? 17. Electrons. Electrons are negative particles. If chlorine has a minus 1 charge overall, which by the way we usually don't write down the 1 part if it's just a negative 1. If it's more than negative 1, if it's negative 2 or negative 3, then yeah, we would write down that number. If chlorine has a minus 1 charge overall, does it have more positive protons or more negative electrons? What do you think, Jackson? Is there more negative electrons or more positive protons when it has a minus 1 charge? More negative electrons. And if it's a minus 1 charge, you would have 18 electrons. So some students like equations to help figure this out. If you recall in the previous page, I gave you an equation, the mass equals the protons plus the neutrons. If it helps you out to figure this type of thing out, the charge of an atom is going to be the protons minus the electrons. 17 protons minus 18 electrons gives us a minus 1 charge. All right, Tess, let's do that with magnesium. Look on your periodic table, find magnesium. How many protons does magnesium have? 12. Electrons. If it is a plus 2 charge, Mike, how many electrons must there be then? 14. Now, if it's 14, we'd have more negatives than positives. Go the other way, 10. Every element has a different mass. Hopefully you've now seen that. Remember, the mass is the protons plus the neutrons, but since there's different versions of each element, different isotopes, it's an average atomic mass in your periodic table. When I show you in front of class a mole of aluminum in this round bottom flask and a mole of carbon in this Erlenmeyer flask, all I had a lab assistant do was measure out a certain mass of it. For the carbon, they measured out 12.01 grams. Because 12.01 is the average atomic mass on the periodic table. All they did for the aluminum was measure out, do I have this one memorized? 26.98? 26.98 grams to figure this out. That's right, Randy. I have all these numbers memorized. And you might have a couple of them memorized before the end of the year. 10 to the 23rd is a ridiculous number of stuff. But why did Avogadro pick out 6.02 to go in front of it? Is because he wanted the average atomic mass on the periodic table, that number in red on the very top. he wanted that number to also be the grams that we measured out on the scale. Because we don't actually have to count out the number of atoms. We can just put things on the scale and find out how much there is of something. We can use that now to do our next step of conversions. So if we're on this how-to sheet, we can use the mass on the periodic table, which is often referred to as the molar mass, because it's the mass of 1 mole, in order to convert from grams to moles or moles to grams. If we look at question number 1 on the sheet, it says calculate the mass of 8.1 moles of cobalt. What I would do is right away write down 8.1 moles of cobalt. Cobalt symbol is CO. Again, as we work on this more, you will get comfortable with these symbols. Abbreviate mole. The question wants us to get to grams, which means grams needs to be on the top of our periodic table. We have moles, we want moles to cancel out. Moles is on the bottom of our periodic table. Emily, what number do I put in front of moles every single time I do a conversion? 1. Notice how our periodic table for the average atomic mass usually gives you a long-winded number. I would prefer we round that off to the hundredth place when we can. It just makes life a little more simple. And I think I see that Kinsey already did that for the first one. Kinsey, what do you have for the average atomic mass for cobalt? 58.93. That means if I had 58.93 grams of cobalt, it would be 1 mole of cobalt. This question says, well, wait, what if I have 8.1 moles of cobalt? How many grams is that? So you get out your calculator. You multiply 8.1 times 58.93. We round off to the correct number of significant digits as well. Melissa, what's the answer? 480 grams. The questions on that first one. Let's skip number 2 then. Let's go right away to number 3. Number 3 says, I have 35 grams of tin. How many moles do I have? And I would immediately write down what I'm given. 35 grams, and SN is the symbol for tin. Tin was discovered back when Latin was spoke, so stannis, stanic, that's what the SN is for. I want to convert to moles, which means moles is on the top of my conversion. Grams is on the bottom because I want that to cancel out. Brooklyn, what number do I always put in front of mole? 1. Lydia, did you find element 50, tin, and its average atomic mass to the hundredth place?
It would be
118.71. So we divide. 35 divided by 118.71. Once again, 2 significant digits in the measurement of 35 grams. Our answer should have 2 significant digits. Tyler, you got a number back there? 0.29. If you wanted to put a 0 in front of that decimal, you can, because that 0 doesn't mean anything of significance. And my unit would be moles. If you wanted to put tin, you can, but right now it's not that important for you to do that.